Hello guys, welcome to Cheenta Statistics Department, and we are going to discuss some exciting problems today as usual. And it's our 5 problem solving session, and so let's get started. I will start with a beautiful probability question, guys, and let's see. It's based on a conditional probability, and let's see how we can proceed towards it. Okay, and this is whatever I'm going to discuss now today. Whatever problem I'm going to discuss, it's based on a really interesting probability argument. Okay, and the probability idea. And So I will just really start with the problem. Okay, so starting with the problem, guys. This is what. Let me discuss the problem first. It's a very interesting, easy problem to tell you. The question is the following: that let Qn, okay, let's say 8. Let Q8 be the probability, sorry. Let Q8 be the probability that in 8 tosses, that in 8 tosses, consecutive tosses of a fair coin. So you're tossing a fair coin 8 times and no run of 3 consecutive heads. The question is, what is this Q8? What is the Q8? That in 8 tosses of a fair coin, there will be no run of 3 consecutive heads. So all of you understood the problem, guys? We are tossing a fair coin 8 times, and in that toss, there will be no coin, so no run of 3 consecutive heads, guys. That's our problem for today, and our main aim should be directed towards what if. What if it's instead of Q8, it's Q100? What is the algorithm to find it? So I will give you a few moments to think about this problem, how to proceed towards this problem. So I can assure you that this problem is based on basic conditional probability. So if you know conditional probability, this problem is perfect for you. Okay? So any ideas, guys, how it's coming into your mind? 8 tosses and no consecutive, like 3 heads. How it can happen? What is the way to think about this problem? Yeah, bolo.
Find the probability for 2 consecutive heads and then subtract it from 1.
No, it's a run, okay? That means it can be 4 consecutive heads too.
Okay.
It's a run, means, it is not like 3 consecutive heads exactly. It can be 4 consecutive or 5 consecutive heads.
So should we frame it as probability of 8 tosses of a fair coin given no run of 3 consecutive heads?
No. We have to find the probability that there exists no, like the event here is that no run of 3 consecutive heads are occurring. For example, in
So
yeah,
this means that only 1, 2 or 0 heads are allowed.
Only 1 consecutive, only 0 consecutive heads or 2 consecutive heads or 1 consecutive heads are allowed,
So from the tosses we can select those and then we can add up.
Perfect. So go ahead and do it. That's what I'm asking you to do. Say tosses, count all the possible scenarios. Yeah, that's a non-conditional way of doing it. Go ahead and find all the possible scenarios where you can do this. 0 heads, 1 heads, 2 heads, whatever you think. Go ahead and do it. Yeah.
So I want it to be very lengthy if we do it that way.
Yeah, I want you to feel that it's lengthy that way. That's why we need something else.
It will be very lengthy. Yes.
But try to find out. Okay, let's do it. Let me try it. Okay. So let's do it for 3
It will
tosses.
be 17.
17. Okay.
Favorable cases will be 17.
Okay, can you tell me the cases?
For one head, there would be 8 cases, since we have 8 places to fit one head.
No. Wait. For one head, total number of cases कितना है?
2 to the power 8.
2 to the power 8. It's first, second, third, fourth, fifth, sixth, 7, 8. So 2 to the power 8. So one heads के लिए, it's heads here, and this 2 will be always tails. And there will be no consecutive heads. You understand? There will be only one consecutive heads. You understand the complexity of the problem, like this.
Oh, okay.
So there will be no 2 consecutive heads.
So can we form a recurrence?
Yeah, who was this?
Can we?
Yeah, so why a recurrence is needed? That's the question. Or why something different is needed. So if you try out this problem, you will understand this problem using the classical probability. It's a fair coin. So the classical probability approach will be really difficult. So you can try it out. Classical probability approach fails. While counting. Okay. So my question is that suppose you know this. So let's, instead of these 3 consecutive heads, so I'm doing it from very scratch so that you can understand how to apply conditional probability. Okay. So now understand this very. Now let's say instead of 2 consecutive heads, I say 1 consecutive head. What will be the answer? One consecutive head. What will be the answer?
So 0 heads.
I mean, 0 heads will be doing that. Let's say only 1 consecutive heads. What will be the answer in that case?
8 divided by
8?
No, not 8. There will be only 1 head, right? So,
No, there will be not. Understand. Only 1 consecutive heads will be there at most.
So head and बीच में दो मतलब head 2 tail के बीच में एक head या फिर head and between. So are you talking about pairs of heads?
5? So even you can understand for 0 heads, you can get an idea. For 0 heads, there is only one option, right? Tails. For 1 heads, it's becoming very difficult. Why? Because heads can be here, then it must be followed by tails. Then heads can be here. So no 2 consecutive heads will be there. No 2 consecutive heads will be there. It can be either tails or heads. But if it's heads, then you have to condition on heads that its previous one is head. See, understand the difficulty over here. So even if you do for, say, let's say 3 tosses, let's say 3 tosses. So 8 cases ke liye, you have to find out, like, let's say only 1 consecutive head, heads, tails, heads. So you have to only make sure that there are no 2 consecutive heads. Heads, tails. Okay. And now you can replace this. So I think we have to subtract those cases where there are 2 consecutive heads. That is this. There are 3 such cases, and this only 1 such case. So it's -4. That is 2 to the power 3 -4. So you have to subtract these cases, right? And so you get 4 out of this. But as you can understand, as you increase the number of heads from 1 to a number of tosses, this 1 consecutive head is becoming too difficult, right? Because there will be heads. There will be heads. Like, you understand the idea, guys? And again, between the heads, there will be a lot of combination. So counting it, so we usually tell what? Classical probability is equivalent to counting. Classical probability is equivalent to counting. We usually tell that. So here counting is itself becoming difficult, really difficult. Or is it? That's the question. So rather, what is the best way to count? The thing, if you could just start counting, you'll understand that whatever the next step is dependent upon whether the previous step is heads or tails. So whenever this comes to your mind, this should give you the idea it's based on conditional probability. Understand this. As you're trying to do this, Suppose I keep it heads over here. Now, depending upon what it heads, the next one we have to determine, right? Whether it's tails or heads. If this is tails, then we can have both. If this is heads, we can have only tails. So it's dependent upon the placement of which of the position, that what are the heads and what are the tails. Like what is the next one. So this must give an idea that, okay, it's like conditional idea is coming. So I must have to use conditional probability. So this is the first thing you guys should learn, okay? That when to use conditional probability. Did you understand? Did you understand the idea, guys? So now we will understand how to apply conditional probability. So this is the way of where to, like, when you should think about applying conditional probability, and this is the idea of how to apply the conditional probability. Okay. Now I will come to the idea that how to apply the conditional probability. The question is that out of 8 tosses, what are the possibilities of getting no run of 3 consecutive heads? Now let's think about this. Suppose you knew the number that you knew the number for n minus 1 tosses. Then what will happen? Suppose you know that the probability out of this n minus 1 tosses, you know that, right? Then how will the nth toss will affect? Understand this very carefully. Understand this. Think about this. Close your eyes and think about this process. What is happening? You are tossing n times, right? Let's do it for n. Let's say do it for 8 also only. So you are tossing 8 times. So understand till the, let's say for 6th time. So if for the 8th time, understand this very carefully. If for the 8th time there are no no 3 consecutive heads, till 6th time is also there will be no 3 consecutive heads, right? What happen? It can happen at most at 6th time. It can happen like this. Okay. So understand this, that out of this, so understand this. What can happen in the 6th, 7th, 8th, 8th, 7th, 6th, 5. So understand that till the 5th toss, say there are no consecutive heads, 3 consecutive heads. Then once we do the 6th toss, what can happen? So my question is that, let's say till 7th toss there are no consecutive heads. Then what are the cases that on the 8th toss it will become consecutive heads? When it can only happen? When this is H and H, right? And it will become H. Did you understand this part? I will explain it again. Let's say you're tossing. The main crux of the idea, I will show you the crux of the idea. Main idea is that if till in a toss there are no consecutive 3 consecutive heads, there are no 3 consecutive heads for n minus 1, n minus 2, ... 1. Did you understand? If till the 8th toss there are no 3 consecutive heads, if we just stop the experiment at 7, then only there will be no 3 consecutive heads. You understand the idea? So when can 3 consecutive heads occur? That's my question. So that's my question. Let's say this is the 8th toss. 1, 2, 3, 4, 5, 6, 7, 8. Let's say you observe the consecutive heads over here. Can you observe a consecutive heads in the 8th? Sorry, can you, so automatically it implies that there will be a consecutive heads till the 8th point. So let's say you have not observed any consecutive heads at the 5th point, okay? Can there be a consecutive heads at the 8th point? That's my question is. So,
yes, sir.
How can it, so no consecutive heads till, no consecutive heads till this point. How can it have 3 consecutive heads here?
So the 6th, 7th, and 8th position will be having heads.
6th, 7th, and 8th position can be having heads. What else?
If the 5th position have an head, then 6th and 7th can also have head.
Exactly. So we will understand the approach like this. Suppose we will understand the approach like this. Understand this very carefully. 1, 2, 3, 4, 5, 6, 7, 8. Understand that suppose in the 8th point there was no heads. Okay. Then if some consecutive heads had applied, have come before, it must be here till the 7th toss. So we are trying to find the probability of Q8. Okay, if 8th position was not any heads, then everything would be in every 3. If suppose the probability of occurrence of no 3 consecutive heads will be same as probability of occurrence of no 3 consecutive heads over here in the 7th point. Do you understand this? If
Yes.
8th position is equal to heads, is equal to not heads, then probability of occurrence of 3 consecutive heads till 8th toss is what? Is equal to Q of 7, right? Because if it has to occur, it has to occur, the probability of occurrence has to occur, then it must have occurred before the 7th toss. Did you understand this simple point, guys? Yes or no? Did you understand this simple point? If the 8th position is not heads, then if 3 consecutive heads must have occurred, it must have occurred before the 8th point, before the 7th point. So it will be not Q of 7, 1 minus Q of 7. So similarly, what we will do, we will condition on the previous step, that what has happened, or condition on what 8 has, okay, and then we will do it accordingly. Okay, when do it accordingly. So let's try it out. Let's say till 7th toss there are no 3 consecutive heads. Let's say till 7th toss there are no 3 consecutive heads. Then what will happen? Then what can happen? Then how can 3 consecutive heads happen?
Then 3, if
One possible way.
Only one possible. Exactly. 6, 7, and 8, right? Both must be heads and heads and heads. All of you understood this? Any doubts? It can happen only in one possible way, right? Perfect. Now let's say till 6th toss, you're right, Devargo. Till 6th toss, there are no 3 consecutive heads. Then how can it happen?
So 5, 6, 7, and 6, 7, 8.
It can be like this. It can be like this. Okay, it can be like this. And then your heads or tails, right? And it can be like this. Here it can be tails or anything. No. There are 2 possibilities. So there are not three. So you have to understand the possibilities now. Okay. So you have to understand the possibilities now. This is the way you have to understand the possibilities. So I will tell you how to find it out. Okay. Let's say till fifth toss. So we'll go to fifth toss. Till fifth toss, there was no three consecutive heads. Then how it can only happen? It can only happen in H and H way, right? The only way it can happen is H and H way. Are you getting confused? So till the fifth point, there was no three consecutive heads. In what way it can happen? That's the question. So you might be thinking that it can be tails and heads, but let's say it's tails. Let's say it's tails. Then how many ways it can happen? If that is tails, then how many ways it can happen? Only one way, right? Did you understand, guys? If the fifth toss is tails, there is only one way, then it can happen. But it is, what I'm telling is it one way it can happen, that it's actually heads and heads and heads. So what is the way it cannot happen? That's my question to you. If till the fifth toss, did you understand it, guys?
It cannot happen when the 6, 7, 8 is not heads.
Yeah. Till the fifth point, you have observed no three consecutive heads. Okay. Then how it can happen that there are no three consecutive heads over here? So I think, so what do you think? Is it easier to do with no three consecutive heads or with three consecutive heads? Bolo. It's easier to do with three consecutive heads or no three consecutive heads? It's easier to do with three consecutive heads. Find out three consecutive heads. Right, guys?
Right.
So let's try to do it for three consecutive heads. So then we will just find out the opposite portion. Okay, that's not an issue at all. So if you want to find out for three consecutive heads, like three or more consecutive heads, it can happen that it ends with tails. If it ends with tails, then here it can only H, right? If it ends with heads, then what will happen?
Then there are two more possibilities.
Then there are two more possibilities.
Two possibilities. Either 5, 6, 7 can be head, or 6, 7, 8 can be head. So it all depends on the ending term of the. If it is less than 6, less than 7 or 8, or 7 or 6, we have to see the ending term. So if it is ending by H, then we check if there is a possibility of getting one head or zero head or two heads.
Okay.
So then we can say that if it is ending with H, then we have to restrict ourselves to two heads only, maximum, at the fifth position. Because at the eighth position, we don't want the head. We don't want the head.
Okay.
So it could be two possibilities. Either I can have one head or two heads. Zero heads or one head, not more than that.
Okay. You can have zero heads or one heads, not more than that.
So then I have only two possibilities to play. Similarly, if I ended by 4, then that's symmetry. It becomes all same. Repeated before.
Makes sense. Okay. I will now given the thoughts you're having, I will give you an idea. The idea is that let's say you have this Qn. Let's say that in it Qn is a probability that no 3 consecutive heads will occur. Show that if you just constrict or restrict it, okay, on the fact that till the seventh position you have no 3 consecutive heads. So it will be 1 into q by n. So it's like this. Q by n is equal to half into q into 1 n minus 1. That is plus something is there, okay? But restricting it to the fact that till the seventh position there are no 3 consecutive heads, then it's the probability of occurrence of 3 consecutive heads, no 3 consecutive heads, is half into that. So how can you do that? How can you show that? Tell me. So the people on the
Please repeat the
live,
question
what
once
ideas?
again.
You didn't understand? Hello?
Repeat the question once again.
Sure.
So,
yeah, bolo.
just a minute. Sir, if we consider a basic recurrence relation,
Yeah.
so can we have n terms of recurrence relation we can have? So, first condition would be we have 0 heads on the first position.
8th position?
Okay. On the first position, we have 0 heads.
0 heads. Okay.
Yeah.
No, that
So
is
we
the
have
idea. So if you start from the first position, now.
Yeah.
If you start from the first position, that will be really difficult. Because it will be just like counting from the initial position. But we don't want that.
No, I am considering a recurrence relation that Qn is a recurrence relation such that there are no 3 consecutive heads.
Okay. No,
So
don't think about recurrence relation. Qn is the probability.
Yeah. I'm saying, okay, An is a recurrence relation where there are no consecutive 3 heads.
Okay.
So we have in the first position that could be only a tail. If there are 0 heads, I'm considering if there are 0 heads, then the first position will be having a tail, and there will be a An minus 1 ka reference, right?
Yeah.
Then I can have either 2 cases. That is, one is either tail head or head tail, or the cases of one head coming in the sequence. So that would be An minus 2 cases. And then I'll be having 2 heads cases. And this is all actually nothing but P of A intersection B. That is, these are 2 independent events, right? The first position have a probability of half times Qn minus 1. Similarly, second have a probability of 1 by 4, AH and HT. So, same. And same goes for HH. That has a probability of tail head H, sorry. That has a probability of 1/8. So we can say half Qn minus 1 plus 1/4 Qn minus 2 plus 1/8 Qn minus 2.
Okay. फिर से बोला the idea really seemed idea, but फिर से बोला the idea you told the first is heads, first is tails.
First is tails. I'm considering that in this recurrence there is no case where I have a head. Sorry, the 3 consecutive heads, and it starts with tails.
Okay.
So I'm considering in this Q1 there is nothing like this. So this An will be having T, और ये जो An minus 1 का sequence बचेगा, that is again following the trend which is जो हमको दिया हुआ है initial condition.
Okay, fine.
Similarly, we can have another case of tail head or head tail, but it's a probability. It doesn't matter what comes before because हम लोग restrict करें उसको 2 ही cases में, tail head या तो head tail, no matter.
No, the first one is it can also be heads, right?
Yeah, it can be also be head. So there are 2 cases maybe, tail head and head tail.
Tail. Now you're considering the first case. It can be only tails, right, or heads? Tail heads. Like I'm not getting this step. You're on the right track.
I'm saying this is the case where the initial places have a head. So consider it to start with the head. So the second position can be head, but the third position can't be a head, right?
Yeah.
Right. So if the first position is head, and if the second position is a tail, then no worries, ना कुछ problem ही नहीं, वापस it can follow the Qn minus 2 trend.
You're telling this?
No, this also, this is my third case, but now I'm just saying HP, that's it, HP. Then now there is no problem. Now it can be Qn minus 2 cases, right? No worries.
Okay.
And then similarly, I have the third case in which there are H, and the third should have to be T. Then there are Qn minus 3 cases.
Yep, perfect. And then?
And then now it is mere probability of having that. Now, so T is just half times Qn minus 1 because the probability of T is half. Same goes for HT, the probability is 1/4. And same goes for HHT is 1/8. And I think it's over there.
Yeah, nice, exactly. So what happens if TH happens? Tell me.
So TH happens, then we have to make sure again H is not there. So that is again Qn minus 3 case.
No,
So
what if? So the general question the students will, you're totally right, okay? I will tell you this, like, I hope others also understood. So suppose it was H over here, then which case it will be in?
So if you are saying it's TH, then I have to check the then there is also no problem. Now, TH and HT are same cases, okay? Na?
No, I'm telling you about in suppose it starts with heads, then
If it starts with heads, then I have to check what is the other term. That is if it's the edge or if it's a tail. If it's the edge, then we go to the third case. That is the Qn minus 3 case. If it's a tail, then it's the second case only.
perfect. Okay, yeah, perfect. The solution is correct. Okay, are you all of you understood? I will explain it again. Perfect. Lovely, nice, Tanvi. So this is the idea. So he was doing from the right and left first toss. I will be doing from the last toss. Okay, it's the same idea though. The first, second. So what he is telling is the following: that let's say the last one is tails. Then the probability. Okay, then the probability of having no 3 consecutive heads is what? Tell me. If the last one is tails, then the probability of having no 3 consecutive heads is what? It's same as probability of having no 3 consecutive heads over here, right? Because this one is not mattering. This is not causing a problem. So it's same as, so given 8th toss is equal to tails, probability, the required probability is what? The required probability, okay, so I will write it like given this format. Probability of, who is joining now? The probability of no 3 consecutive heads given 8th toss is equal to tails. This probability is what? Probability of no 3 consecutive heads till the 8th toss, given the 8th toss is tails, is what? It's same as probability of no 3 consecutive heads till the 7th toss, right? Did you understand this, guys?
Yes.
Okay, what about others? Then we understand, no? What about others? Dev, Tishika, Suryanshi, Mihika, Bhushan, Tanvi, Sneha. Did you understand? Tejash. Okay, so probability of 3 consecutive heads, no 3 consecutive heads till the 8th toss is same as probability given the 8th toss is actually tails. is same as probability of no 3 consecutive heads till the 7th toss. Why? Because if, let's say, you may be, because it's the same thing, like if it is tails, there is no possibility of having 3 consecutive heads. Okay, give the given till the 8th time point. So there was no possibility of having it. So if any possibility of like 3 heads are occurring or no 3 heads are occurring, it will happen only inside, like before the 7 tosses. Okay, otherwise it will not happen. So this is the first idea. Okay, so if it's heads, then what will happen? If the, so therefore the next condition is that if the 8th toss is heads, where is my, if the 8th toss is heads, then what will happen? If the 8th toss is heads, then understand this can be HH or HT again. So we divided into 2 cases, HH and HT. If this is HT, understand again the same idea that till the 6th toss, so understand this probability no 3 consecutive heads till 8th toss, given the 7th toss is tails and the 8th toss is heads, is what? Is same as Q of 6, right?
Yes.
All of you understood this idea? If HT in this case, not in this case.
Yes, sir.
So understand clear? All of you understood? Everyone? Good. Now, for HH क्या होगा? For HH again there are 2 cases, HH और HHH. अगर HHH हो गया तो वो cancel case. So therefore we have this only possibility that HHT. ठीक है? Till HHT it will be again Q5 again. Okay, and all the possible cases are done. So what are the possible cases? 8th toss is H, 8th toss is T. Okay, then it's Q6, Q7. If 8th toss is H and T, then it's Q6. If 8th toss is H and T till the 8th toss, then it is Q5, and H is not possible. So these are the all possible cases. H, and then under, if it's H, then it will be HT or HH. If it's HH, then it can be HTA, HHT or HHH. H it will not be possible. So only this. So we have 3 possible cases. Therefore, 3 partition disjoint cases, guys. So therefore, how to write this result down? How to write this formally down? Understand this. Let A be the event that no 3. Understand how to write it down in PSB and ISI, okay? How to write it down, rather you have to practice it. No 3 consecutive heads till 8th toss. Let A be that. And let OT be the output of ON be the output of nth toss. So ON follow Bernoulli half. Sorry, okay, let's not think ON. So probability of ON is equal to H is equal to probability of ON is equal to tails is equal to half. So A is probability of no 3 consecutive heads till 8th toss, this. So now let's write it down 8th toss. Let's write it down like this. 8th toss is tails and then yeah, it's heads. The two cases. 8 tosses, tails, or heads. If 8 tosses tails, then 8 toss. I'm drawing the tree diagram, okay, that I have taught you in the last class. Then it can be heads or tails. Then it can be heads, okay. Okay, whatever the H toss is, this is not okay. I will just share with you this new way of doing it. If it's the tails, guys, if it's tails, then you can understand that the probability of toss now is Q of 7. You understood it. Okay, so how to write it down? Probability. So okay, I will write it down. So this is actually equal to probability of A given 08 is equal to tails. Probability of A given 08 is equal to tails. This is equal to Q7. Okay, suppose it's heads, then there can be two cases. Heads or heads tails. That's right. Tails are off. Heads, tails, and heads. If it's heads tails, then again what we have that it's Q6, which is equal to probability of A given Q08 is equal to heads and 07 is equal to tails. And if it's HH, there are again two cases, tails and heads. If it's tails, then it's equal to Q6, Q5, which is equal to probability of A given 08 is equal to heads, 07 is equal to tails, heads, and 06 is equal to tails. And this is not possible. This is probability 0. Okay. Then how to write the entire probability? This is by the entire diagram. So what you get is that probability of A is therefore what? It can be probability of A given 08 is equal to tails into probability of 08 is equal to tails plus probability of A given 08 is equal to heads and 07 is equal to tails into probability of 08 is equal to heads and 07 is equal to tails plus this is exactly what is the idea of law of total probability. A given 08 is equal to heads, 07 is equal to heads, and 06 is equal to tails into probability 08 is equal to heads, 07 is equal to heads, and 06 is equal to tails. So what do you get from here? You get that now. So why I'm writing this down? If it's an objective, I wouldn't explain this, but it's always good to know. Now understand this. This is equal to half because these are independent trials. This is equal to 1/4. This is equal to 1/8. Sorry. And these are what? Yeah, understood. This is actually again repeating the same thing. It's Q of 7. It's Q of 6. It's Q of 5. So what is this happening? It's happening that it's 1/8 into Q of 5 plus 1/4 into Q of 6 plus half into Q of 7. All of you understood this, guys? Did you understand this? Did you understand this, guys? Dev, Tishika, Suryanshi, Mihika, Bhushan, Tanvi, Sneha, Tanveer.
I have a doubt.
Sure, go ahead. Please tell me.
Just scroll up. Yeah. Why did we take only one case at 08 will be H and 07 tails? We can also consider that 08 will be tails and 07 will be tails. They're not
Oh, yeah, very good question. So she's asking exactly what I was asking. I was wanting this question exactly. Is the following. She was asking where does this tails case go? Understand the tails case go in here only when the first toss is tails. It automatically goes in here only. Because if the first toss is tails, if somehow the probability that no heads is occurring, that is exactly same as Q7 because nothing extra is changing. So if tails is happening, it automatically happen going into this case. You can ask what happens if heads tails heads, or what happens. You can ask that what if tails and heads occurs. See, if tails and heads occurs, automatically goes into this case, the Q of 7 case. Did you understand or not? Let's take a case. Let's do it for 4 tosses, okay? So how we are doing? For 4 tosses, we are doing like this, that tails, and then whatever the previous tosses are. So the only way it can happen, like it is like this. No heads can happen. We can take all the possibilities down. We can write all the possibilities down. No 3 heads can happen. It will not be a concern because if something no 3 heads have happened over here, it's same as probability over here because this T is actually the point that it's breaking the loop. So if something could have happened over, it's not happening because it's T over here. So whatever if H would have been here, it is considered in this case only. Q7 that I am telling. Did you understand this, Neha?
Yes, I got the point. Basically, we are conditioning on the last event.
Exactly, because it's because we are conditioned on the last event just because it considers our case, and just because the previous case is dependent upon this case via the last case only. So if something couldn't have happened, even if the last case is there, that is actually included in the Q7 part. That's already calculated in the Q7 part. Let's say tails, heads, tails is a case which we are not considering because we are considering tails. But it's already considered in here. Why H is not a possibility? Because if H is there, then this possibility ke liye, this is a problem. This possibility ke is a problem. So it is not a case. So we need HT over here to again do that same thing. If something T over here, that's automatically included in this because it's not breaking the loop. The only thing that is breaking the loop is H. That's the only case. Did you understand, Sneha?
Yes, I understood.
Very good. Lovely. So this is a basic idea, guys. This is a basic idea. So what we have got for n events, what we will get is that for n events, we will get Qn is equal to 1 by 8 into Qn minus 3 plus 1 by 4 into Qn minus 4 plus half into Qn minus 2. What I am doing? Qn minus 1. Also understood that for n it will be the same thing. Did you understand? Any doubts? Dev, Tishika, Polomi, Suryang, Mihika, Bhushan, Tanveer, Sneha. Any doubts? No doubts? Clear? Good. See, in this case, what you have to do is that you have to. Thanks for the boom. Yeah. Okay. Perfect. So let's see what we can do else.
So can we have a question on occupancy cost?
Oh, you have to tell me this before the class so that we can do it next day. So if you have some suggestions, please tell me before the class, okay? Like before the class means at least one day before the class so that I can like take all the people's doubt and do that. Okay. Okay, what else we can do? Okay, this is also on the same ground of conditional probability is the following. Pn is the probability that. So what we are doing is the following. The independent trials that result in a success with probability P and a failure with probability 1 minus P. Okay? Success with probability P and failure with 1 minus P. Like heads or tails you can consider. Okay? And Pn is the probability that in such trials, in such short tosses, result in even number of successes. Then find the probability Pn. Try to use conditional probability. Try to understand this. This is actually based on the fact that these are based on the fact what happens in the previous one. Okay, so try to use this property of conditioning, guys. It will really help you. That's why I'm just helping you to understand this. Did you understand the problem? Each independent trials can result in a probability, a success rate with probability P and failure with probability 1 minus P. So what is the probability in such tosses result in even number of successes? That's my question. That's my question to you. So you're telling me something, actually I cannot hear you. Give me a minute. Give me a minute. Again, there's some problems. Just give me a minute. One second, Tanvir, 1 second. Yeah, bolo. It's not working fine.
So is it half?
Wait, some people have some doubts. Wait. So Polam is asking, what is the question? Question is this. Find the probability that we are doing n such independent trials. What is the probability that n such tosses will lead to even number of successes? The number of successes will be even.
So if it's a failure, if we start with a failure, then there are Pn minus 1. No, then there are terms which you have to subtract. Now, they should be not there.
Yeah.
Like if it starts with the success.
Yeah.
Okay. Then the other part will be always success. It starts with success, then it goes success only. And then there are remaining Pn minus 2 terms.
But I'm not getting it.
Similar to the question we did.
So you're telling that, let's say the last one is success. That's why I'm given the same question idea. So we are trying to find a number of success. Let's say n. Let's say n. That this is n minus 1. Say. So let's say n. So if the last one is success, then here there are what? Odd number of successes.
Yes.
If last one is failure, then here what? Yeah.
If the last one is the failure, then we have odd number of successes. And if we have
no, we want to understand we want to have even number of successes, right?
Yeah. So if we have last term as failure, then there are n minus 1 successes are right?
No, I'm asking about the number even. So it's asking that out of the same tosses, what is the probability the even number of successes will be there? So if last one is success, then the probability the even number of successes will be there is same as probability odd number of successes n minus 1, right? Understand this?
Yeah.
If someone was telling me something. Yeah, I think someone was telling me something. Mihika, Tanvi, Tishikas. Sneha, someone you were telling me something? So the last one is success. If the last one is success, then
the second last should be success only.
no, it cannot happen like that also. It can happen like success,
The
success.
last one is success. Then the rest of, like for n minus 1, like you said, we should have odd number of successes.
Exactly.
Odd, and then this one, it will add up to the even number.
Yeah. So odd number of successes will be there. So out of n minus 1, odd number of successes will be there. What is the probability of this? It's 1 minus Pn minus 1, right? Pn is actually probability of even number of successes out of n tosses. So out of n minus 1 toss, odd number of success means what? 1 minus Pn minus 1. If the last one is a failure, out of n minus 1, there will be even number of successes. So the sum goes to even. So how many ways you can do that? It's Pn minus 1. Did you understand, guys? The probability. Do you understand this? So there are two cases. I'm conditioning on the last one. I'm conditioning on the last one. So how will I write it? Probability even in n, even s in n, can be written as two ways. It's the probability even s in n given last is equal to s into probability last is equal to s, plus, or it can happen like this, even in n tosses given last is equal to failure into probability last is equal to failure. Then even s in n given last is equal to failure is what? This is same as probability odd in n minus 1, right? And this is even in n given last is equal to failure is what? Probability odd, probability even in n minus 1. All of you understood the red step, guys? Understood the red step? Dev Verma, Tishika, Suryanshi, Tejas, Bhushan, Tanvis, Sneha, Tanvi.
So I did not understand the last part.
So understand this. So if we are looking for n even number of tosses or successes in n tosses, okay?
Yeah. Yeah, sir, but okay, wait, I think I missed one point. Like, why were we considering like 5 cases? Like, we're just taking an assumption for 5 cases right now.
5 cases? Where does 5 cases come up?
No, last 5.
Last is equal to s.
Okay.
So we are conditioning on the last case. Last, what should I say? We are conditioning on the last toss. If the last toss is success, then to get even number of successes till the nth toss, we must be having odd number of successes in the n minus 1 tosses, previous tosses.
Yes.
That is what this means, this red portion. If the last one is failure, then to get even number of successes in the nth tosses is same as getting even number of successes in the previous n minus 1 tosses. So this red part is coming. Okay, did you understand, all of you? Follow me.
Yes, sir.
You will join. Did you understand this problem now? Yes. All of you understood it? Tell me yes on the chat box. So this, understand, all of it is a law of total probability. So probability odd in n minus 1 is what? It's same as p into n minus 1 into last one is a success, that is probability p is happening. Sorry, 1 minus p for the odd part. It's odd in n minus 1 into last is equal to success plus probability even in n minus 1.
Sir, I don't understand why there is 1 minus Pn minus 1.
Oh, Pn minus 1 मतलब क्या? Even number of successes in n minus 1. So 1 minus Pn क्या होगा? Not even number of successes, that is odd number of successes in minus 1.
Okay, sorry, my bad. Sorry.
No, it's okay. So even number of successes in minus 1. So 1 minus P क्या होगा? 1 minus P is probability last is equal to failure. So this is the idea. So we get Pn is equal to, what do we get? Can someone calculate? I think we got 1 minus P into Pn minus 1 plus no, I'm doing something wrong. 1 minus P for this and 1 minus 2P into Pn minus 1 plus P. So understand this is coming. Pn is equal to 1 minus 2P into Pn minus 1 plus P. So you can solve this equation now. You can solve this now. Reconciliation. How to solve this? Simple. Pn minus 1 is equal to 1 minus 2P Pn minus 2 plus P. So you replace it over here. So you get that Pn is equal to 1 minus 2P whole square plus 1 minus 2P. Sorry, 1 minus 2P into Pn minus 2 plus 1 minus 2P wait, 1 minus 2P, we put it over here. Yeah, this plus P. Okay, if you again do it, replace Pn minus 1, you will get that it's equal to 1 minus 2P whole cube into Pn minus 3 plus 1 minus 2P whole square into P plus 1 minus 2P into P plus P. So dot dot, you will get that. So what we know? P of 1 is what? P of 1 is that 1 means out of 1 tosses, we have even number of successes. That is 0 successes is what? Out of 1 toss, we have 0 successes is what? Is 1 minus P?
1 minus P.
So we will use the base case, the boundary condition. So till this we will continue till P1. See 3 and minus 3, n minus 3 and 3 adds up to n. So it's like n minus 1 and P1. Plus here it will be 10 minus 2. Dot 1 whole into P will be common. So you get that Pn is equal to 1 minus 2P whole to the power n minus 1 plus into Pn, that is P1 into 1 minus P, that is P1, plus this sum into P, that is, this turns out to be 1 minus 2P 1 minus 1 minus 2P whole to the power n minus 1 by 1 minus 1 minus 2P into P. It turns out that this turns out to be 2P. So P and P gets cancelled over here. So you get that 1 minus 2P whole to the power n minus 1 into 1 minus p plus half minus 1 minus 2p whole to the power n minus 1 by 2. So you get that if you take this 2 common, you get actually 1 plus 2 into 1 minus p minus 1 whole to the power 1 minus 2p whole to the power n minus 1. So get over here, it's 1 minus 2p whole to the power n by 2. So this is equal to pn. All of you understood this, guys? Did you understand this, guys?
Yes.
Others? Sneha, Bhushan, Tanvi, Suryanshi, Tejas, Dishika, Dev.
So basically, first we replaced Pn minus 1, then Pn minus 2, and then this process goes on and we keep simplifying and we get this. Right?
Yeah. Your main aim is to remove the PNs. So that you can get the whole thing out. Yeah, that's the simple step. Did you understand?
Yes.
This is a way to solve. This is called 1 degree, like only one way to, like, you have to delete those parts which are iterating. That's the idea. And we know how to delete things, iterating things in life. So yeah, this is the way out. Okay. So yeah, so we did 2 probability, conditional probability problems, guys. And yeah, that's it. So next day on Saturday, again for the 2022 people, conditional probability problems will be done more along with the real answer and linear algebra problems. Okay, guys. So yeah, so the first problem was a bit hard.
Sure.
Yeah. Bolo.
Sir, this week's assignment you were supposed to.
Yeah, I will be giving by Sunday. All the assignments. I am actually preparing all the assignments of linear algebra real analysis also, so that I can give it to the whole set. Don't worry. I will give it to you by this Sunday. Yeah. After the Saturday's class, I will give you.
Okay.
Yeah. Okay. All of you understood today's class? Any doubts? Okay. No doubts. Okay. Fine. Okay. Let's end the class. Bye bye. Good night.